we are in a discussion of AWS Solutions Architect, and we be discussing about EKS, Elastic Kubernetes Service, right? And we discuss Elastic Kubernetes Services comparing into a modern smart building, which how they work all together, right? And this video, we're going to discuss more about Kubernetes clusters and their components, right? Let me briefly discuss, one slide what we discussed in my previous video with Kubernetes. Explain simply, right? Kubernetes container orchestration, right? So what we did in my previous video, we just comparing the Kubernetes cluster in one of the smart modern building in our city as a real world example. So in a building manager analogy, right? Think of Kubernetes as a smart building manager for your application, right? So we called apartments are equal to containers, right? That's your applications. And then we discuss flows are equal to pods, group containers. The flows might have one single apartment or different apartment, right? And then the buildings are nodes, servers, and the manager is Kubernetes orchestrate everything. That is the orchestration management panel, whatever the panel, whatever we use for managing everything, all Kubernetes clusters, right? So basically, what is Kubernetes? Kubernetes is the open source container orchestration platform, right? This is what we do. Basically, is a container orchestration that automates deployment, scaling, and management of container application because clusters of machines. So as we as we compare this one for building, so we get the three buildings there. So that's called three nodes servers, and then each building you got rows. Rows we say is pods. The pods are group containers. They say one building has one row, five apartments, five units that container count, and then apartments in containers got your application. So it's key benefits of Kubernetes services, right? Answer most resource applications. What is the workload coming? According to that, the resources to get more resources or less resources, and self-healing, so restart their containers automatically, right? So anything happen, they will restart and try to make it will happen, or if it's not working, it's remove and or get a new pods or containers, and then load balancing. So you get your load balancer distribute traffic efficiently. So zero downtime deployment, so update without interruption. So part of them can be upgraded while the other part is working, right? So a lot of real business problems solved. So downtimes, reduced downtimes will get high availability, and then a lot of information going inside that. So it will get less overhead, and then improves resource utilization and accelerated deployment from weeks to minutes. So that's easy to deploy, right? Or let's go back into our the more about building blocks of this Kubernetes, right? So what we're going to discuss, about the pods, right? So before we go into this picture diagram, we discuss about what are the the pods, right? So it's one of the major building blocks of Kubernetes cluster. So the smallest deployable unit in Kubernetes is called a pod, right? So pod can contain one or more containers that share resource and network, right? So it says key inside the pods are ephemeral. Ephemeral means they come and go. So pod can be one single container or a bunch of containers. Number of containers might be 1, 2, 3, 4, 5. Number of containers, right? Is called a pod. Pod is a group unit, right? And so, what are these characteristic of pods? Pods share single IP address. All containers share one IP. Let's say you have one IP 192.168.1.5 or something. So if you have 5 containers inside that pod, the containers share that one IP address, right? It's similar, something like you can think about something like the like virtual machines. We have virtual machines, and then we can no, can't. I don't think a virtual machine we can compare that, but this is like you sharing one single IP address, right? And then a shared storage. So volume accessible by all containers. That volume, let's say you could have one of the shared volume. The shared volume will be accessed by all 5 containers. If you could have 5 containers, and then the ephemeral nature, temporary by design. So they comes and go, right? The atomic unit scheduled together on same node, they all scheduled together, right? And then you have port life cycle. So what is this port life cycle? What is the life cycle of ports? Because as I said, they come and go, right? So pending, waiting for scheduling, and then running. Running means actively executing whatever the code to your application, and then succeeded, complete successfully, and then failed, with the terminated with errors. Let's say that one came up with some errors, and then unknown. It's a communication issue, right? So that is a sort of uh, terminated. So this is a part of a life cycle, right? Okay, let's looking into bit of its nature, right? So you have a single container pods in one of the Kubernetes cluster, and then multi-container pods. We call the main container plus sidecar container. Like let's say it's a looks like it's sort of auxiliary helping something. It might be a used for logging the sidecar container. Let's say you got a motorcycle and you have seen you put another um, wheel, and then you put a sort of a side, just like a side apartment into the motorcycle. So it's become a sort of a three wheel sort of a motorcycle, one side, a motorcycle in your side, you got a sort of things you can carry some of extra stuff. When you go somewhere, let's say you want to carry some bags and other stuff, so sidecar. Mm, it's a similar sort of things like the like you attach one of the trailer into one of the vehicle, and it will help, but the major thing is when you destroy the port, the sidecar also goes with that, right? So that is what port sidecar. So the container might be a logging or sort of believe with it sort of purposes, right? It's an auxiliary part. So uh, let's look into container patterns, right? Container patterns, and then we'll go to this one. This one of single container port. So most common pattern, one application per port, right? So one application per port, and then multi-container ports. Sidecar, helper containers, logging, monitoring, right? Init containers, so set up the domain container, right? Uh, AWS EKS specifies, right? EC2 modes, port run on manage EC2 instances, right? And that is you use EC2 instance to run for port, right? And then Fargate mode is serverless. There's no EC2 instances, serverless port execution without node management, and then scheduling. AWS handles the node provisioning and port placement automatically, right? So that is automatically settlement security IAM roles for service accounts, right? Uh, so that is like a security management, right? So container patterns, right? Uh, the main containers start after init completion. So there are stages like init one, and then main container app will created, and then init two, the sidecar container coming down. Right? So and it's how these ports, if we explain the ports going up, and then now let's go these pictures. So it's Kubernetes port life cycle timeline, right? So you see this one just giving you a life cycle timeline, right? So this access uh, 200 for seconds, 200 means nearly if we think about 1 minute here, another minute here, and 3 minutes here, and nearly another 40 seconds and 24 minutes, right? So for the life cycle takes us go from here in this direction, right? So you got a few places of building, running, succeeded, and field, and no, right? So here it's a 30 seconds, 30 to 120 seconds running and active execution, right? So this is what is happening. So pending, image pulling, scheduling, volume mounting, right? And this is the container sort of is called that you building up containers, right? Then here all either they are succeeded or failed, right? Completions of running container executing, and then you check health checks, and then you use resource usage, right? And then these third one also you can see the task succeeded, failed, 120 to 180 completion, right? If it's either it succeeded, the task completed, right? Or it's the code received, so keep clean up region. And then also got a field containers clean up and errors that could be 180, that means nearly 3 minutes class. So the stages are error stages like communication lost, node issues, and network problems. So that's a start as either termination or uh, rebuilding, restarting. So these ones would call Kubernetes life cycle. So that is pending and running, and then results succeeded or failed, and then stage unknown state, right? So let's go to our next section. All right, so one solution architect should consider AWS EKS. EKS is right? EKS is more complex than ECS. So AWS managed infrastructure handles Kubernetes control panel management, updates, and patching automatically. So that is the one advantage. And then you can see auto scalability, scaling capabilities, ports and nodes based on demand. And then you can do um, identity and access management, IAM integration, and network isolation. So cost optimization, you pay only compute resource you use with the export. Also export instances support for price reducing database integration. So many services are integrated with the AWS interfaces like K3 buckets, RDS, relational database system, and then AWS Lambda, all other services. So eliminating infrastructure management complexity and audit. Right. So the major thing is it's going to be multi-variabilities on deployment with the 99, 95 service level agreement and comprehensive monitoring through CloudWatch. Right. Just refreshing. Just refresh. Oh, like refreshing. All right. So that's good. Right. All right. So comparing AWS EKS to other Kubernetes solutions, right? So why we normally compare with what are the other services providing to AWS EKS to other Kubernetes solutions. So Kubernetes is a general solution, so many providers providing, right? So so many solutions, the other providers like my competitors, AWS EKS, a deep AWS integration, and Google autopilot mode, right? And then Azure Kubernetes service DevOps things, right? So table wireless solution and then management cost and vendor looking. All right, so AWS EKS, right? So management is low, right? Low overhead, and then zero point 0.1 dollar per hour. And vendor locking in high, and then Google Kubernetes service so lowest. Management is the lowest for all of them, and then the same cost, and vendor locking is high, and then you got to Azure Kubernetes services, and that is low, and cost is free, right? And then vendor locking is high. I think it's even a Kubernetes service is free, but you probably be getting charged for services, whatever you use. So self-managed is management is high management. If you create your self-management, and the cost going to be very well, and then vendor looking up, right head open shift. Its management is a bit of a medium, and then the cost is premium. Hasn't mentioned how much is actually. So vendor looking is a medium, right? And then Kubernetes. So what are the real advantage of Kubernetes or self-managed full control over cluster, custom configurations, and high operational overhead, right? Kubernetes platform comparison. Let's discuss about what are the that's the comparison, platform comparison each year. So there is ease of use, integration capabilities, cost effectiveness, feature richness, vendor independence and enterprise support. So you can see here each color different providers like AWS EKS. It's sort of red color, not red. I think it's a sort of orange red, and the word GKE. Uh, so blue. These ones are sort of blue, so harder to determine. But if we go here, you can see how much the how much they compare to each other, right? Um, so going to choose each EKS AWS heavy environment. So your other environment like a lot of your resources are in AWS cloud, so you can use EKS GKE Google as Kubernetes. So if you have your other resources are in Google Cloud, so you can use Google Cloud Native. So then, if your resources are in Microsoft heavy log based, so you can go to Azure Kubernetes services, and then if you got like a Linux based sort of environment, you can go OpenShift enterprise feature, right? So key considerations of team expertise and skills, which area your team needs and expertise, uh, existing infrastructure investment, um, um, and then compliance requirement, and then you can see budget constraints, right? Budget constraints that how going to decide this Kubernetes services, right? That actually is sort of a all right, so this is a core architecture of AWS EKS, right? So it's just like basically how the things are working, right? And this is mainly AWS EKS cluster, right? So the cluster is here, right? And then you get a control plane, and then data plane here. And in here, data plane, you got work nodes, containers, right? And then you have ports connected to that, right? Uh, Control panel, and then API server, and etcd database, control manager, and then that is the control panel, and then high availability is there, right? So that is how the connected like cluster is here, and then you got a data plane, and then a control plane, right? And API server, etcd database, control manager, ports, and then a container manager. So if you have a look at this picture, this is taken by AWS documentation, right? So see, a lot of other services integration, how works this code work as a code, right? So, so this is the case cluster here, right? Private subnet, and then you have load balancer here, right? And with load balancer here, you got the Amazon S3, sorry, Cloud 53 and then users right, users are interacting with this one, and then this is a development team is AWS code pipeline, right? And then AWS code and AWS code build, and then Amazon Elastic Container Registry, where you keep and then see here. So elastic network interface, right? So the deployment done. So deployment UI, right? Force UI, force app, right? This is the whole class. And then this is shared network interface, right? And they all characteristic DC, right? So VMs, database workloads, right? Gateway, and in this it has zero router connected to nothing, right? And ESXi clusters built an easy to bare metal instances of such complex. So that complex setup, right? That is outward picture coming, right? So key security features. So EKS infrastructure separation with include image cluster can't be overall communication from other clusters expected polarized, but Kubernetes are that practice, right? All right, component in an EKS, right? So we still are discussing a sort of a component related. So component in EKS, see, as we say, it's control plane control panel, you got API server, EPCT, and then a scheduler, control manager, and then here the book nodes, right? Proxy, and then container runtime, right? Book node goes to proxy and container runtime, right? And then API server controller, correct, and then ports, and then containers. So this is all controller plane, control plane, business plan, and controls of AWS EKS Kubernetes as the orchestration engine to fully manage control plane across multiple availability on for high availability. This is whole structure. So control plane manage the overall state of Kubernetes cluster with components like API server, etcd, scheduler, and then controller manager. The work can also run containerized applications within pods managed by Kubernetes and Kubernetes proxy components that communicate with the control panel. Then a security gets multi-layer security, IAM integration, and RBAC granular access control to cluster resources. Right. That's what you got in. All right, I think we got nearly 30 minutes now. Let's see who can make a one more um, video regarding this EKS. Until then, thank you very much.